Hi everyone, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video lecture, we are going to see about RC oscillators. So, at high frequencies, commonly LC tuned oscillators are used, but they are not suitable for low frequency applications because the design of inductors and capacitors would be very bulky. So, RC oscillators are found to be more suitable at low frequency operation. Two important RC oscillators are RC Phase Shift Oscillator and Wien Bridge Oscillator. So first is RC Phase Shift Oscillator. In this oscillator, the required phase shift of 180 degree is obtained in the feedback loop and the remaining 180 degree phase shift is produced by three set of R and C elements. So each RC element set produces 60 degree each phase shift. So totally we are getting 180 degree phase shift. So the total phase shift produced by this RC phase shift oscillator is 360 degree. So just look at the transistor. The transistor produces 180 degree phase shift and 3 RC sections produces 180 degree phase shift. Thus the resultant phase shift is 360 degree. So this is the circuit diagram of RC phase shift oscillator. So which is actually a voltage divider bias circuit into which in the feedback loop 3 RC sections are connected. This is the equivalent circuit of RC phase shift oscillator. When solving this circuit, we are getting F0 is equal to 1 by 2 pi RC into root 6. If the value of R and C are chosen for a given frequency F0, then the phase shift of each RC section is 60 degree. So such the RC ladder network produces a total phase shift of 180 degree. Therefore, at specific frequency F0, the total phase shift from the base of the transistor around the circuit and back to the base will be exactly 360 degree, thereby satisfying the Barkhasan criterion of oscillation. And the frequency of oscillation is given by F0 equal to 1 by 2 pi RC into root 6. At this frequency, it is found that the feedback factor of the network is beta equal to 1 by 29 because we know that the condition for oscillation is modulus A beta equal to 1 and we know that A is equal to 29, therefore B should be equal to 1 by 29 and this factor should not be less than unity. So the required condition for magnitude of amplifier is greater than 29. So this is the condition required for maintaining sustained oscillation. The RC phase shift oscillator is suitable for audio frequencies only. Its main drawbacks are that the three capacitors or resistors should be changed simultaneously in order to change the frequency of oscillation, and it is difficult to control the amplitude of oscillation without affecting the frequency of oscillation. So the condition for maintaining sustained oscillation is given by substituting alpha is equal to root 6 into the equation of beta. So that we get beta is equal to minus 1 by 29 and in terms of polar coordinates minus 1 can be replaced by 1 at an angle 180 degree. So that we are getting the magnitude of beta as 1 by 29 and its phase is 180 degree. Hence, a transistor with gain less than 29 cannot be made to oscillate in a circuit and the frequency of oscillation may be varied by changing any of the impedance elements in the phase shifting network.